there are four transformations. The first one is reflection, then we have rotation, then we have enlargement, and finally we have translation. Reflection is flip. You take something and it's reflected. As you can see, it's like a mirror image. You just flip it around. Rotation is you just turn it. So if this is the object, you can turn it. When you turn it, it becomes rotated either in the right hand side or on the left hand side. So this is reflection, which means flip. This is rotation, which means turn, either towards the right 90 degree or towards the left 90 degree, or you can turn all the way around 180 degree, or you can enlarge it, enlarge, which is resize. Just change the size like you do in any software. And there's another one called translation. Translation, it means you just slide it around, slide, taking from one place to another. That's what happens. So when we do this, let me take this. If I take this and if I just rotate it around like this, so this is 90 degree in the clockwise direction, or I can rotate it around in the 90 degree anti-clockwise direction, or I can rotate it all the way around here. Doesn't matter which direction, either clockwise or anti-clockwise, I'll end up in the same position. This is 180 degree. Now when we resize it, we just take something and we pull it. That's it. We resize it. This is enlargement. We resize it. Now when we talk about translation or sliding it around, we just slide it around, taking it here or take it there, just slide it around. That's all we do. So think about a triangle. We have a point over here, then we have a point over, point over here, and we have a point over here. So this is the triangle. Let me join it. Okay, so this is the triangle. Let me call this A, B, and C. Now if I reflect it on the x-axis, this point A, if x-axis is the mirror, let me count it. 1, 2. So it would be 2 boxes further away from the mirror, the x-axis. So 1, 2. So this would be the new position of A. Let me call it A prime. Then B is going to be 1, 2, 3, 4. So 1, 2, 3, 4. So B prime is the new position of the image. And then this one, 1, 2, 3, 1, 2, 3. Remember, the object is always the same distance from the mirror as the image is. So this is the image. Reflection on the x-axis. Now on the other hand, if this was reflected on the y-axis, then it would be like this. So if now this is the mirror, the y-axis is the mirror, so this A is one box away from the y-axis, so the image would also be one box away from the y-axis. So let me call this A prime. And this is one box away, this would be one box away, let me call this B prime. And then again 1, 2, so 1, 2. So let me call this C prime. So this is the reflection on the y-axis. Okay, now if I were to draw a line here in the through the origin, that line would be called the line y equals to x. This would be the mirror. So let me call this the mirror. Okay, now if the line y equals to x is the mirror, in that case we would have the image as one away equal distance from here. Then it has to be the same distance from here. So this would be A prime, this would be C prime, and B prime would be from here, around here. So this would be B prime. So the triangle would look like this. Okay, so this is roughly. So what I'm writing here is reflection. So reflection, these three are the common reflections, or what we do is flip it. We flip. So we flip, this is the, let me call this the original object. Each of them is an image of this object. Okay, so triangle ABC, we flip it in this way, we call it reflection on the line y equals to x. We flip it on the other side, we call that reflection on the y-axis, and we flip it and we call this reflection on the x-axis. So there can be many types of flips. I can draw another line by myself and just flip it on that line, so it doesn't really matter. Well, all these things can be done using matrices. So if I were to do this using matrices, first of all I have to convert the coordinate of the point into a matrix. So the point, this point A is x coordinate is 1, y coordinate is 2. So I would write it like this: 1, 2, the x above and the 2 below. And the coordinate of B would be x coordinate 1 and y coordinate 4. So it would be 1, 4. And then C would have x coordinate 2 and y coordinate 3. So 2, 3. So we found the matrix which has 2 rows and 3 columns. So the matrix of the object. Now we need to figure out the matrix with which we can transform. So reflection on the x-axis. So this is x-axis reflection. So what we need, a transformation matrix over here. Now a little bit about transformation matrix. Transformation matrices are like this. It's an identity matrix. It is going to be 2 by 2 in size. So 2 by 2 in size. It's going to be an identity matrix, means it's made up of zeros and ones. And the first row would be x coordinate. Let me call it xa and let me call it xb. And the second row is going to be y coordinate. Let me call it ya and let me call this yb. So the transformation matrix is made up of zeros and ones, and it is going to have values of x and at the basic levels, the values of x in the first row and value of y in the second row. Now you think of a single transformation matrix like this. So if you are thinking about the x-axis, so the point, if the point is here, image is here, object is here, and then you reflect on the x-axis, then the image is going to be here. So the x value is going to be the same and the y value is going to be negative. So the transformation matrix would be x is going to be a. So xa is 1. So then there is no b. So 1, 0. And b, y coordinate is b. So it's going to be 0, minus 1. So if it's negative, so minus 1. So that is going to be the transformation matrix. So this is the transformation matrix for x-axis. So we can continue with the sum. So this is going to be 1, 0, 0, minus 1. So all we do is we multiply and we're supposed to get this image, which we can do by actually counting. So let's multiply. So you know the multiplication, the row is going to be the column over here. So 1 into 1 is 1 plus 2 into 0 is 0. So 1 plus 0 is 1. And this is going to be 1 plus 0 again. So this will be 1. This will be 1. 2 plus 0 again. So this would be 2. So here now this would be 0 into 1. So this horizontal row is going to be multiplied with the vertical. So 0 into 1 is 0. So now all we know is that all these y coordinates are going to be negative. So minus 2, minus 4, minus 3. Look, we could have just thought about this. X coordinate is same. So 1, 1, 1, 1, 2, 2. The y coordinate is negative. So 2 minus 2, 4 is minus 4, 3 is, or we can just multiply this. So this is the image matrix. So the image is, if we can check whether this is indeed right or not, we can see that a coordinate is 1 minus 1. So this is 1 and this is minus 2. So this is 1 minus 2. So it is correct. Then the b prime coordinate is going to be 1 minus 4. So 1 minus 4. This is also correct. And so on. This is 2 minus 3. So we have this. We have a transformation matrix. Let me call this matrix M. A transformation matrix, which would be a 2 by 2 identity matrix for reflection. The most common transformations, they would be like that. And then we multiply this with the object matrix. So object matrix. The object matrix, if it's a triangle, it would be it would have 3 columns as 3 coordinates, and it would always have 2 uh, rows because of x coordinate and y coordinate. And we are going to get the image matrix, all in matrices. So this is how the whole thing is working. So if we move on to the reflection on the y-axis, we can still figure out the matrix. So the matrix would be y-axis. So if you have a point over here, A, B, that point would be, the x-coordinate would be negative because this is positive x. The second quadrant has negative x. And the y-coordinate would be same, plus b. So the matrix is XA, XB. Since the image x-coordinate is minus A, so it would be XA negative, so minus 1, 0. Now the y-coordinate. So y-coordinate is B. So B means the second position. It would be 0, 1. That's how it is written. So similarly, if we take this triangle and multiply with this matrix, so in that case, this time let me take this minus 1, 0, 0, 1. And the object is going to be the same from the beginning. So it's, let me write this down, 1 2 1 4 2 3. You don't even have to multiply this. You know the point AB would be minus AB, so all the x coordinate would be negative, the y coordinates would be same. So I can just simply write minus 1 minus 1 minus 2 2 4 3 just by remembering this picture. Or you could actually go through the multiplication. Minus 1 into 1 is minus 1, plus 0 into 2 is 0, so minus 1. Minus 1 into 1 is minus 1, plus 0 into 4 is 0, so minus 1. Minus 1 into 2 is minus 1, plus 0 into 3 is 0, so minus 2. Or then 0 into 1 is 0, plus 1 into 2 is 2, and on and on. And we can also check with this. So A prime is going to be minus 1, 2. So x coordinate is minus 1, y coordinate is 2. So this is minus 1, 2. B prime 1, 4 is minus 1, 4. So let's check. This is minus 1 and this is 4. This is minus 1, 4. And we have the C coordinate minus 2, C prime coordinate minus 2, 3. So this is going to be minus 2, 3. So that's how this thing works. Now, another one we have here is reflection on the line y equals to x. So reflection on the line y equals to x. So what happens here, if this is the mirror and the point AB, by the way, the point doesn't have to be in the first quadrant, it can be in any quadrant, but it helps to arbitrarily think of any point that's in the first quadrant. But it doesn't matter, it will work with any point anywhere, it doesn't really matter. So the image would now just be flipped. It would be BA. Let's check. For example, when we did this physically, this point was 1, 2, and look here, when we see the image, it is 2, 1. This point was 2, 3, and look at this point, this is 3, 2. It just flips. So that's what happens. So anyway, based on the image, we write the transformation matrix of B. So x coordinate is going to be B. So 0, 1. So the position of XA is 0, the position of XB is 1. And the y coordinate is A, so it's going to be 1, 0. So that's the transformation matrix. So let's do this as well. So we can write 0, 1, 1, 0. Remember, this is the main rule of when you have a transformation, you multiply the transformation matrix, this time the flip matrix, with the object matrix, and you get an image. So we can multiply with this. 1, 2, 1, 4, 2, 3. You can multiply this, or you can just flip it. So 1, 2 would be 2, 1. 1, 4 would be 4, 1. 2, 3 would be 3, 2. That's it. Now, if you're asked to define, describe, and describe fully the transformation from which this object comes to this, or this object comes to this, and on, this is how you define it. This is the description. The object, name the object ABC, is reflected on the line, mention the equation of the line, x-axis, y-axis, or it could be any other line actually. It could be a line x equals to 4 where you can count and find where it is reflected on the line, but usually it's x-axis, y-axis, and y equals to x on the line to give the image. So that's it.